video is about statistical independence. Independence is where the occurrence of one event has no effect on the probability of the occurrence of the second event. In statistics, there are two formulas we can use to prove independence. We can check whether the probability of A and B occurring equals the probability of A occurring times the probability of B occurring. Another formula we can use is to check if the probability of A occurring equals the probability of A occurring given that B occurs. Logically, this makes sense because if the probability of A equals the probability of A given that B occurs, that means that it didn't matter whether B occurred or not. And that's exactly what independence is. The occurrence of one event has no bearing on the occurrence of the other event. What that looks like mathematically is checking if the probability of A occurring equals the probability of A and B occurring over the probability of B occurring. Something that gets easily confused with independence is being mutually exclusive. Mutually exclusive events are those that cannot occur together. Independent events are where one event occurring has no effect on the other event. Although they sound similar, they are actually very different. Let's see. Can mutually exclusive events be independent? No. Think about it this way. We know that mutually exclusive events cannot occur together. So when one of those events occurs, it very much affects the probability of the other event because now it is impossible for that other event to occur and its probability drops down to 0. This is something you could easily see come up in an AP exam, and you should know that a mutually exclusive event cannot be independent, and those are thus dependent events. Now, let's work out an example to put all of this into perspective. When selecting one card in a standard card deck, check whether selecting a card that is red and is a 7 are independent. Let's say that event A is a card being red and event B is the card being a 7. We know that there are a total of 52 cards in a standard deck, and half of those cards in the deck are red. So the probability of event A occurring is 1/2. We also know that any number in a card deck can occur 4 times. So when we divide that out in our calculator, we get 0.077. Now, let's apply one of the checks for independence that we have learned. So if we go back to the first slide, here are our 2 checks of independence, and I will be showing you the second one over here because it's a little more complicated, and I feel like we would need an example to be able to go over that. Okay. Now let's check if the probability of event A occurring, equals the probability of event A occurring given that event B occurs. So in context, we are checking whether the probability of drawing a red card equals the probability of drawing a red card given that the card is a 7. Something that you need to know for the AP exam is the formula for the given that statement. So when you see this, you should be able to expand it into this form. You need to know that this is going to be P of A and B over P of B. I like to think that the second event in the given that statement is what goes in the denominator, and that helps me remember it. We know that and means multiplying, and when we plug our probabilities into this formula, we get 1/2. This matches with the probability of event A, and the 2 events are therefore independent. That's all for this video. Thank you for watching, and good luck studying!